Hey everyone, welcome back to the lectures for Privacy and Machine Learning and Statistics. Today we're going to start with a quick overview of where we are in this part of the course, which covers query release algorithms. Then we'll talk about a model that's not on its face related to data privacy, which is called the online learning model. And we'll see a specific algorithm for that setting, a classic algorithm called the multiplicative weights algorithm. In the next lectures, we'll be covering how this online learning setting and the multiplicative weights algorithm specifically connect to data privacy and query release in synthetic data generation. So just to sort of give us a picture of where we stand, we've been looking at different methods for query release. So we're given a set of queries, usually linear queries, and a data set, and we want to design a differentially private algorithm that will take that data set and release the values of all the queries on that data set while not revealing, while continuing to be differentially private. And the algorithms we've seen for that so far use data independent noise addition. Okay, so we saw the Laplace noise algorithm, we saw the Gaussian noise algorithm. So these are the very simple ones. And then we saw this idea of factorization and projection, which helps us handle structure in the sets of queries and maybe certain types of redundancy in the sets of queries. So today we're going to, well, over the next few lectures, rather, we're going to see a sort of a second class of these algorithms that are based on synthetic data generation. And specifically a view of this, of synthetic data generation as some kind of two-player game. All right, and so the idea is that if we can generate a synthetic data set that agrees with the real data set in all, with respect to the frequencies or the answers to all the queries we're interested in releasing, we can design a differentially private algorithm that generates like a fake data set that has the right values of all the queries. Then we can just publish that and people can compute the answers to the queries they want themselves. So that's going to be like the big idea of using synthetic data to do query release. And we're going to see that there's this connection to a whole other set of topics dubbed online learning, or sometimes online decision making. And what we'll see is this sort of general connection between online learning and synthetic data generation. And we'll take a specific algorithm for the online learning setting called the multiplicative weights algorithm, classic algorithm that you may have seen in a previous course. And we'll see that we can use this to generate algorithms for the for synthetic data generation. The one we'll see first is called multiplicative weights via the exponential mechanism. So usually pronounced MWEM, or sometimes pronounced MWEM. And then there's another variant, online private multiplicative weights, which came first historically, but we'll probably see second. And then what we'll hint at is actually a sort of a more general version of this connection that really that will try to explain the reason that online learning is so useful via a connection to equilibrium computation in a certain two-player game. Two-player zero-sum game. Okay, a game we'll call the data generation game. And we'll see that if we kind of go, that the connection that we'll sort of use this view of a two-player game to generalize the connection between online learning and synthetic data generation. And that will give us some other algorithms for synthetic data generation, like the dual query algorithm and a few others. And along the way, we may see some other online learning algorithms like follow the perturbed leader, which is a funny name, and maybe some others. Okay, so broadly, this is where we are. So today we're going to be seeing, as I said, we're going to see this model for online learning. And then we're going to talk about the multiplicative weights algorithm. And then in over the next few lectures, we'll see these other connections, these sort of various other objects in this picture, and sort of fill in the parts of this picture. So it doesn't all have to make sense yet. We're going to get there.